Bismillahirrahmanirrahim. Assalamu alaikum students. This is Tariq. Today we will discuss another concept of the mathematics of finance, the concept of compound interest. What is compound interest? When the interest earned in the first period is added to the principal amount or reinvested in the principal amount to earn further interest in the next periods, this is called compound interest. When we reinvest the interest earned, so the principal amount in the account is expanding, increasing, interest rate will remain same, and when the amount is increasing, so it will earn more and more interest in the next periods. Important instructions about the compound interest. Interest rate I is interest rate per compounding period, where I is the symbol which define interest rate per compounding period. How we can compute interest rate per compounding period? By dividing the given annual interest rate by the number of compounding periods per year. In this way we can define interest rate per compounding period. As this is given here, I is equal to annual interest rate whole divided by number of compounding periods per year. I am again repeating that I represent interest rate per compounding period. How one can define I, how one can calculate I using this formulation. I is equal to annual interest rate whole divided by the number of compounding periods per year. N prime, N and this dash that represent prime. N prime, what is N prime? Number of compounding periods per year, where N prime is N prime. What is N? Where N represent the total number of compounding periods in time T. How one can compute total number of compounding periods? By multiplying the number of compounding periods per year with the total number of years, as the formulation is given here to compute the total number of compounding periods in time T. N is equal to N prime multiplied by T. I am again repeating, I is interest rate per compounding period, N prime define the number of compounding periods per year, and N define the total number of compounding periods in time T. We are deriving formula for the compound amount. So compound amount formula derivation. Suppose we are generalizing this approach. I am putting a general example, and from this general example I will develop the compound amount formula. Example is this: if one deposit principal amount P for n number of compounding periods at I% interest rate per compounding period, define the future value of the saving account. Means that one individual deposit principal amount P for n number of compounding periods at I% interest rate, so define the future value of this saving account. Now future value formula of the saving account we study in the previous lecture. Sn is equal to P plus Pin. In the previous lectures we put Sn is equal to P plus PRT. Now we change in the compound interest I for R and N for T, where I define interest rate per compounding period, where N define number of compounding periods in time T. I am again repeating, S is the accumulated amount, is the sum in n number of periods. So P is the principal amount and Pin is the interest earned in the n number of compounding period. Sn is equal to P plus Pin. P is the principal amount, initial investment, I interest rate per compounding period, and total number of compounding periods in time T. Now we are developing compound amount formula by starting one by one to compute the future value of the saving account for every period when one invests principal amount P for n number of compounding periods at I interest rate per compounding period. So this is the formula, Sn is equal to P plus Pin. Now I am putting value n, mean future value of the saving account after first compounding period, so I am putting N1 because we are defining the future value of the compound amount after first period. So S1 is equal to P plus Pi. Why I am not putting n in here? Because the value of n is 1. We are calculating the future value of this saving account after first compounding period. So we replace for n1, and 1 multiplied by Pi is equal to Pi. So S1 is equal to P plus Pi. This is the future value of the saving account after first compounding period. We can write this formula like this as well. By taking P common, we have S1 is equal to, when we take this P common, P take outside. When we take this P outside, 1 is remaining here. Plus, when we take this P outside, I is remaining here. So S1 is equal to P into 1 plus I. This is the future value of the saving account after first compounding period. Future value of the saving account after second compounding period, we have S2 is equal to S1 plus S1I, but S1 is equal to P into 1 plus I. As we know that future value formulation is Sn is equal to P plus PRT, or Sn is equal to P plus PIN, but now when we compute the future value of the saving account for first period, so interest earned is added to the principal amount and the principal amount now change. So that is why I change the symbol for the principal amount in the account in the second time period also. In the first time period, the symbol was P. Look, you can see in here, this was the principal amount. This is the principal amount in the first period. After first period, the principal amount changed to S1. Why? Because interest is also added to the principal amount, and when interest is added to the principal amount, so principal amount increase, expand, and we change the symbol also from P to S1. So that is why, student, do not confuse that what does this S1 and S1 mean. This is the new amount in your saving account in which interest also add. So S1 plus S1I. Again, this is P plus PIN. So P is now S1 plus S1I. This is the principal amount in the account, plus this is interest earned in the second period. You can see here future value of the saving account after second compounding period. So now principal amount in the account after first period is S1, and this is the interest earned in the second period, which is S1I. But S1 is equal to P into 1 plus I. That is why by taking S1 common, we have this S1 is common in these two terms. We take outside. When we take S1 outside, 1 is remaining here. When we take this S1 outside, I is remaining here. So now this is the new status of the formula. S2 is equal to taking S1 common multiplied by 1 is remaining here plus I is remaining here, and now S2 is equal to S1 multiplied by 1 plus I. Now in the next step, we will substitute the value of S1, which is P whole multiplied by 1 plus I we are substituting in this formula the value of S1. So this is S1 and the value of S1 is P into 1 plus I. We replace for this S1 its value, this P into 1 plus Y in here. So S2 is equal to P into 1 plus I whole multiplied by this statement 1 plus I. Now P whole multiplied by 1 plus I whole raised to the power 2. Why? Because 1 plus I is the same in here. When we multiply both, we will add the power. Base is same, power is 1. 1 plus I raised to the power 1, 1 plus I raised to the power 1. When bases are same, power must be added. So 1 plus 1, 2, we can write S2 is equal to P into 1 plus I whole raised to the power 2. Now this is the future value of the saving account after second compounding period. Now future value of the saving account after third compounding period. Again we will repeat the same process. Now this is S2, future value after third compounding period, S3 is equal to S2 plus S2I. Again I am repeating, this is P plus PI. But why I am putting S2? Because this is third period, and in the first two periods the principal amount earned interest 2 times, and this is added to the principal amount. That is why in the third period our principal amount in the account is S2 and plus S2I. The value of S2, this is very clear from here, S2 is equal to P into 1 plus I whole raised to the power 2. We will replace for S2 its value. By taking this S2 common, we have, when we take this S2 common, 1 is remaining plus I is remaining. Now this is the future value of the saving account after third compounding period. I am again repeating, future value of the saving account after third compounding period. So future value formula, Sn is equal to P plus Pi, but now this N is third compounding period, so S3 is equal to S2 plus S2I. What does this S2 mean? This S2 is the principal amount in the saving account after 2 compounding periods, when the 2 times interest earned and added to the principal amount P. So principal amount increase in the account, and that is why we change the symbol P from P to S2. So this is S2, which is the principal amount in the account after 2 compounding periods, or you can say in the third period. So S2 plus S2I, the value of S2, we take S2 common, we have, now we will replace for its value in here. S2 is a P whole multiplied by 1 plus I whole raised to the power 2 whole multiplied by 1 plus I. Again here bases are same, 1 plus I raised to the power 2, 1 plus I raised to the power 1. So when the bases are same, the powers must be 8. So 2 plus 1, P whole raised to the power 1 plus I raised to the power 3. And now we are proceeding because investor deposit principal amount P for n number of compounding periods at I% interest rate. So this is the future value of the account after third compounding period, now after fourth compounding period, after fifth compounding period, after sixth compounding period, and so on. Sn is equal to P into 1 plus I raised to the power n. This is the future value of the saving account after n number of compounding periods. So we develop formula for the compound amount. Future value formulation of the compound amount, we develop formula Sn is equal to P whole multiplied by 1 plus I whole raised to the power n. We can use this formula to compute the future value of the compound amount, or to compute the future value of the saving account. To be continued. Interpretation. After n number of compounding periods at I% interest rate per compounding period, bank will pay total Sn is equal to P into 1 plus I whole raised to the power n amount to the investor. This is just generalized approach. Now let me further elaborate this compound amount formulation and the future value of the account by putting one detailed example. For example, determine or define the future value of the saving account if one deposit $20,000 at 8% interest rate per quarter for 4 quarters. Means define that how much the bank will pay to the investor after 4 quarters, mean after 1 year, if the investor deposit presently $20,000 at 8% interest rate per quarter. So answer. First we have to collect information, data, an initial investment P, that is $20,000, interest rate per quarter, that is 8%, which implies 0.08, and the number of quarters N is equal to 4. Total number of quarters are 4, this is given. that investment is for 4 quarters, mean for 1 year. Now by putting all these values, P $20,000, interest 8% per quarter, total number of quarter 4 in the compound interest formula, we have Sn is equal to P whole multiplied by 1 plus I whole raised to the power n. Now n is 4, so we substitute for n as 4, so this is S4, means accumulated amount in the account after 4 quarters. Initial investment P, that is $20,000, 1 as it is, plus interest per quarter 0.08 whole raised to the power number of quarters 4. Again $20,000 as it is, S4 is equal to $20,000, 1 plus 0.08 is 1.08 whole raised to the power 4, and again S4 is equal to $20,000 whole multiplied by 1.3604. So 1.08 whole raised to the power 4 will give us the value 1.3604. 20,000 multiplied by 1.3604 is equal will give us S4 is equal to $27,208. What does this $27,208 means? Interpretation: after 1 year, means 4 quarters, bank will pay to the investor $27,208. I'm again repeating that if investor will deposit $20,000 at 8% interest rate per quarter for 4 quarters, so after 4 quarters bank will pay him total $27,208. To be continued. I am putting another example. For example, what is the future value of the saving account if one deposit $10,000 for 5 years at 6% annual interest rate compounded semi-annually? Semi-annually mean the bank will pay interest twice in a year. I'm again repeating example that what is the future value of the saving account if one invests $10,000 for 5 years at 6% annual interest rate but compounded semi-annually. So in here, first we have to change the annual interest rate 6% to the interest rate which is compounded semi-annually. Measurement units are not same. Given interest rate is annual, time is years, and interest rate that the bank will pay to the investor, that is semi-annually. So answer, first we have to collect information. P, initial investment $10,000, interest rate, but this is annual interest rate 6%. This is not interest per compounding period, this is annual interest rate, where R define annual interest rate. T, number of years, 5 years time period. In prime is equal to 2, means semi-annually, compounded semi-annually. This means the bank will pay interest twice in a year, and we are using the symbol in prime for that. N represent the total number of compounding periods. How one can compute? N is equal to N prime multiplied by T. It's mean number of compounding periods per year multiplied by the total number of years. So number of compounding period per year 2, total number of year 5, 2 multiplied by 10. It's mean the bank will pay in 5 years 10 times interest to the investor. Now by putting all the values like P $10,000, I 0.03. Now look, we change the annual interest rate 6% to the I interest rate per compounding period. Divide R by the N prime. 6% divided by 2 is equal to 0.03. You can say 3%, means that I is interest rate per compounding period. The given interest rate is annual 6%. We have to change annual interest rate to semi-annual. So we will divide 6% by 2, and that is 3%. The total number of compounding, that is 10. The bank will pay interest 2 times in a year. The number of years are 5, so 2 multiplied by 5, the bank will pay total 10 times interest to the investor. Put all these values in the compound interest formula. We have Sn is equal to P whole multiplied by 1 plus I whole raised to the power n. N is very clear, that is 10. We substitute in here. P is very clear, $10,000. We substitute in here. I is very clear, 0.033%, and again N is 10. Again, S10 is equal to $10,000 whole multiplied by 1 plus 0.03, 1.03 whole raised to the power 10. S10 is equal to $10,000, 1.3439. When we put this value 1.03 whole raised to the power 10 in the mobile, so in the calculator, so we can compute the value of 1.03 whole raised to the power 10, which is 1.3439. $10,000 multiplied by 1.3439, we have S10 is equal to $13,439. What does this mean? This means interpretation. Interpretation is this, that if investor will invest $10,000 for 5 years, bank will pay him $13,439 in future. Note, compounded semi-annually means bank will pay interest twice in a year. If this is compounded quarterly, then bank will pay interest per quarter 4 times in a year. I am again repeating this interpretation, that if investor will invest $10,000 now for 5 years at 3% interest rate compounded semi-annually, so the bank will pay him $13,439 after 5 years. Now, present value of the compound amount. In this section, we will learn that if the future value of the saving account, interest rate per compounding period and number of compounding periods are given, how to compute the present value initial investment of the saving account. In this section, we are going to define that how much currently investor should invest if the bank is ready to pay him some amount in future. Interest rate is also clear, number of compounding periods are also clear. So we are going to develop the present value formula for the compound amount. Formula for the present value of the compound amount. Note, we can derive present value formula using future value formula of the compound amount. I am again repeating that we cannot compute the present value of the account without the future value of the account. If the future value is given to us, we can compute the present value. Without future value, one cannot calculate the present value of the compound amount. So in here, from this note, we mean that we can develop present value formula using future value formula. Without future value formula, we cannot develop the present value formula. This is the future value formula of the compound amount. Sn is equal to P whole multiplied by 1 plus I whole raised to the power n. Solve for P we have. To solve for P means keep the P alone on one side and transfer all the other terms to the other side. Divide both sides by 1 plus I whole raised to the power n. We have Sn whole divided by 1 plus I whole raised to the power n is equal to P into 1 plus I whole raised to the power n whole divided by 1 plus I whole raised to the power n. Simply, students, divide this left hand side and right hand side by 1 plus I whole raised to the power n. We have this 1 plus I whole raised to the power n cancelled by 1 plus I whole raised to the power n. So P is alone now. Sn whole divided by 1 plus I whole raised to the power n is equal to P. We can write as P is equal to Sn whole raised to the power 1 plus I whole raised to the power n. P is equal to Sn whole divided by 1 plus I whole raised to the power n. We can take this 1 plus I whole raised to the power n from the denominator to the numerator as well, and now this is P is equal to Sn multiplied by 1 plus I whole raised to the power minus n. So this is the present value formula that one can use to define the initial investment, the principal amount of the account. Let me further elaborate by putting one example. For example, what is the present value of the saving account if the bank is ready to pay $13,439 after 5 years at 6% annual interest rate compounded semi-annually? Answer. Information. Interest rate is 6%, where R is annual interest rate, number of year 5 years, Compounded semi-annually means the bank will pay interest to the investor twice in a year. So N prime represent number of compounding periods per year, which are 2. N define the total number of compounding periods in time t. So N prime multiplied by t. The bank will pay interest twice in a year. Investment for 5 years. So 2 multiplied by 5 is equal to 10. It means the bank will pay interest 10 times in 5 years. So S10, the future value is $13,439. Note, A's given interest rate is annual interest rate 6%. We will change R to I, interest rate per compounding period, by dividing R by number of compounding period per year, as I told you in the previous lecture also. I is equal to R whole divided by N prime. I is interest rate per compounding period, and we can change annual interest rate to interest rate per compounding period by dividing the annual interest rate by the number of compounding periods per year. By putting all the values, S10 $13,439, interest rate I per compounding period 6 divided by 2 3%, total number of compounding period in 5 years 10, and the present value formula of the compound amount we have. P is equal to Sn multiplied by 1 plus I whole raised to the power minus n. P is equal to NS10. 1 plus interest rate is semi-annually 0.03 means 3%, whole raised to the power minus 10. P is equal to 13,439. 1 plus 0.03 is 1.03 raised to the power minus 10. Again P is equal to 13,439 whole multiplied by 1.03 raised to the power minus 10. Now 1.03 whole raised to the power minus 10 is equal to 0.74409. When we multiply 13,439 with 0.744, so we will find $10,000. P is equal to $10,000. What does this $10,000 means? This means that if investor will invest $10,000 currently now in his saving account at 3% interest per compounding period for 5 years, the bank will pay him in future $13,439. Interpretation: if one will invest currently $10,000, bank will pay him $13,439 after 5 years at 3% interest rate per compounding period.